Several times have students complained of always being afraid of problems in moments. So that very fear is what we want to crush this morning. All right, now let's look at this problem. A uniform meter rule AB with a mass of 80 grams hung at the 95 cm mark, balanced horizontally on a knife edge placed at the 80 cm mark. Calculate the mass of the meter rule. This question is pulled from NACO 2022. All right. Now, in attempting to solve this problem, it is imperative to understand that a meter rule has a length of 100 cm and 100 cm is equivalent to 1 meter. All right. Now, since the meter rule is uniform, it implies that the center of gravity of the meter rule is at the 50 cm mark. Now, let us have a sketch of the problem. All right. Now, it says a uniform meter rule AB. So here is A and here is B. And here is the zero end, while here is the 100 cm mark. Okay, now it says it has a mass of 80 grams hung at the 95 cm mark. Now, 95 cm is somewhere here. So here is 95. And at that point, we have a mass of 80 grams. This is the mass of 80 grams hung at that point. It says that this meter rule balanced horizontally on a knife edge placed at the 80 cm mark. Now, 80 cm is somewhere here. Remember that this meter rule is not drawn to scale. Okay, now, here is the knife edge at the 80 cm mark. Here is 80. All right. It says calculate the mass of the meter rule. Now, remember that I said initially that the center of gravity of the meter rule is at the 50 cm mark. So here is the center of the meter rule, and here is 50. And that is the point where the resultant weight of the meter rule appears to act. The center of gravity of a body is defined as that very point where the resultant weight of the body appears to act. All right. Now, we know that the distance from 80 to 95 is 15. And the distance from 50 to 80 is 30. Now, we are now going to use the principle of moment to solve this very problem. Remember that the moment of a force is defined as the magnitude of the force multiplied by the perpendicular distance of that force from its line of action. All right. Now, here is a mass of 80 grams. And this 80 grams is a function of force. Remember, from Newton's second law of motion, that force is a function of mass. Now, this is the force, and the distance is 15. So now the clockwise moment, we're going to look at the clockwise moment. This is the clockwise moment, while this is the anti-clockwise moment. All right. Now, the clockwise moment about the pivot is equal to the force times the distance, and that force is 80. So we have 80 multiplied by the distance from here to here is equal to 15. Okay, now the anti-clockwise moment is equal to the force here multiplied by the distance. Remember that the mass of the meter rule acts at its center of gravity. Let us call the mass of the meter rule m. So the moment about this very point is force times distance. That is a m multiplied by 30. All right, I hope you are getting what we are saying. Now, remember that the principle of moment says that for a body in equilibrium, the total clockwise moment must be equal to the total anti-clockwise moment. Okay, Now, if we apply the principle of moments, clockwise moments is equal to anti-clockwise moments. Okay, now the clockwise moment is 80 times 15. So we have 80 times 15 is equal to, the anti-clockwise moment is m times 30. All right, now 80 times 15 will give us 1200. And this is equal to m times 30 will give us 30m. So to find the value of m now, we have to divide both sides by 30. So that means that m is equal to 1200 divided by 30. Now this, we cancel this. Now 120 divided by 3 will give us 40 grams. So that means that the mass of the meter rule is equal to 40 grams. Thank you very much for your audience. Please don't forget to share our videos and subscribe to our YouTube channel. God bless you.